Welcome to Simonton Windows. As one of the nation's leading manufacturers of premium vinyl windows and patio doors, our employees take pride in every custom-built product we make. We hope you enjoy this unique video tour as you'll experience the special techniques and craftsmanship required to make the windows that are ranked highest in customer satisfaction by J.D. Power and Associates year after year. Manufacturing a window or door to Simonton's high standards is no easy process. In fact, it requires several processes and teams working together in precise harmony to maintain the consistent quality our customers have come to expect from us for over 65 years. As an industry leader, we have refined our manufacturing value proposition to deliver the industry's shortest, most dependable lead times. Let's get started on our tour. There's a lot to see. Glass is one of the most significant components in any window unit. It is the largest surface area of any window product, so it makes sense that the preparation of it is a very important part of the entire window manufacturing process. Each sheet of glass goes through a special process to prepare it to be placed into an insulating glass unit, or IGU. To cut the glass into precisely measured sheets, we use dual-headed automated cutting systems. These dual-headed machines cut both the inside and outside panes of glass at the same time. They cut with extreme precision, at the optimum pressure, and spray a light coat of oil along the cutting path. These factors work together to greatly reduce stress cracks from occurring in the final product. Here you see sheets of cut glass. Notice the small amount of oil that was sprayed along the cutting path. This optimized cutting system also greatly reduces the amount of scrap glass produced on our lines. We average less than 10% in scrap glass, but the small amount that does end up in the scrap bin is recycled. Before the glass is washed and tempered, or heated to add strength, we must first soften the edges on a grinding table. As a sheet of glass is tempered and is cooled, the heat rapidly leaves the pane at its edges. If the edges are not first softened, the glass will shatter during the tempering process. Both top and bottom edges of the sheet of glass are smoothed simultaneously by a grinder. During this same stage in the process, we etch data on the corner of the glass in ceramic ink to make it easy to identify as a tempered piece of glass. This ink is ultimately baked into the glass in the leading ovens. The sheets are sent through a special washer before tempering. Notice the brass brushes that come in contact with each piece of glass sliding into the washer. These special brushes help the line operators ensure that the low E coating is on the correct surface. After a thorough washing to remove any debris or particulates, each sheet of glass in a Simonton window goes through a heated leading oven. In this two-step process, the sheets of glass are heated to a scorching 1400 degrees Fahrenheit. Where the tempering is actually accomplished, the sheets pass through two cooling stations. At the first station, we blast the surface of the sheets of glass with cold air. This causes the glass to cool from 1400 degrees down to 400 degrees in around 4 seconds. The cooling process is completed at a second station, where special green inspection lights under the tables help operators identify any blemishes in the glass panes. After the glass is washed and tempered, it is important to build it in an insulating glass unit as quickly as possible to keep any contamination out of the sealed airspace. Highly efficient insulating glass units are built from 2, often 3, panes of glass that are separated by a low conductance spacer system. Since the area of a window where conditioned air is most likely to escape is at the edge of the glass, spacers work to greatly minimize the transfer of heat or cold between the two panes of glass once the glass unit is sealed. Simonton's Supercept spacer system that you see here features a U-channel design and is made of a stainless steel alloy for superior thermal edge performance and increased strength. As Supercept comes off this line, the spacer is cut and notched at precise points, so it will easily snap into a shape that corresponds with the edges of the pre-cut panes of glass. The spacer also contains special custom holes into which the grids will be inserted. This rigid spacer system is ideal, helping to ensure grids stay locked into place over time. Here you see Super Spacer being applied to a pane of glass. Super Spacer is a flexible, non-metallic foam-type spacer system that also significantly reduces heat transfer. Its flexible design makes it the best choice for curved windows. All flat and sculpted white and tan grids are roll-formed in our plants. Here you see spacers and grids that are assembled and ready to be mated with the glass to build the insulating glass unit. Once we have completed the spacer and grid processes, these components are assembled into insulated glass units, or IGUs. We sandwich the panes of glass and the spacer together. At this station, we see hot butyl being applied along the edges of an insulating glass unit with Super Spacer. This creates a solid thermal barrier at the edges of the glass and ensures it will perform as it was designed. Once butyl is applied to the edges of an IG unit with a rigid spacer, like Supercept, seen here, it is moved into an oven to be heated to a sealing temperature. Once the unit reaches the exact temperature, rubber rollers press the glass down to its specified insulated glass thickness. This process also makes a more reliable seal by pressing the butyl deep into the pores of the glass. Our glass cutting processes, combined with our sealing process, work together to ensure that our insulating glass units are virtually failure-proof and built to last for years. The air that gets trapped inside an insulating glass unit has moisture in it, so we must dry them out so condensation does not form between the panes. This drying is accomplished by adding a matrix that contains a desiccant that absorbs the moisture that is trapped in the air inside the IG. Here we see argon gas being inserted and sealed into some IG units. Argon gas is an odorless, non-toxic gas that is much denser than air, and it is an excellent insulator. This process not only inserts argon gas, it also draws out air from the IG unit and analyzes the makeup of that air. This analysis ensures that we are inserting the optimum mixture of argon and air. After the optimum mixture is transferred into the units, it is sealed off with butyl. These units are then placed on special racks and transferred to the glazing lines, where they will be inserted into the sash. And the sash is then inserted back into the window mainframes. Simonton Windows is vertically integrated, and we manufacture all of our own lineals at Simex, our dedicated vinyl extrusion facility. Once extruded, these lineals are shipped to our various plant locations across the country, where they are precision cut and welded together to form sash, frames, and accessories for our products. On our sash and frame lines, 21-foot vinyl lineals are fed into the line where 45-degree miter saws cut the profiles to exact measurements. There are typically 2 saws per line. Any waste generated from the process is captured and recycled. After the profiles have been cut, they are ready to be fabricated. Much of the fabrication process still involves expert craftsmanship and includes altering the profile to allow for weep holes, notching out lift rails, that are integrated into the sash profiles, creating punch-outs for lift handles, Simonton's patented lap lock meeting rails, and tilt latches. Pneumatic punches are used to create the necessary notches and holes in the profiles. After the frame and sash profiles are fabricated to order, they are moved to an area to be fusion welded together. Fusion welding is a very important part of the window manufacturing process. Each product Simonton manufactures is custom built to our customers' exact specifications. Our automated welders ensure that each sash and frame are manufactured to their precise measurements. Through barcode scanning processes, the welders determine the exact measurements of the unit and move to the appropriate size. If there are any discrepancies, it will become very obvious right here. 95% of the welding we do is done on these special 4-point welders. Welding all 4 corners of the units at the same time ensures that we create it perfectly square. These special welders will also weld more than one sash at a time, ensuring a square, matched set for those particular units. The jigs on these fusion welders match our profiles precisely to make sure there is no twisting or warping at the miter and that each profile aligns perfectly. The welders are set at 509 degrees Fahrenheit and the profiles are heated for around 10 to 12 seconds. As the heated Teflon-coated plates move out of the way, the profiles are then pressed together and given 10 to 12 seconds to cool. After this welding process, the burn-off is cleaned off the miter with special weld cleaners. Automated routers and scarving knives safely clean the welds for speed and quality. This attention to detail through automation ensures that all sash and frame welds are consistent and evenly matched on each unit we manufacture. The next phase of the fabrication process involves fastening hardware. Operational components such as pivot bars, airlocks, and slider rollers will all be fastened in this area. Dual thin wool pile weather stripping is carefully applied and secured to each unit to help ensure a weather-tight seal and reduce callbacks. There are multiple areas in our plants where weather stripping and sill bulb material is applied because of the many different pieces of weather stripping we use. We also use closed-cell foam siliconized vinyl-coated weather stripping on the bottom and top of the sash. In the area of our plants where we fabricate the window mainframe, both left and right hand jambs are cut simultaneously. We use 2 completely different profiles for our jambs and sills and fusion weld them both together to make the mainframe. So the process to allow a cutting angle for the sill and the jamb to match is very complex. Most manufacturers simply use one profile for both jamb and sill, creating a pocket sill, or they mechanically fasten the sill to the jamb. Once the jambs have been cut, they are fabricated for installation screw holes, balance takeout holes, and jamb adjuster holes. After the balances have been inserted into the mainframes, they are now ready to be fusion welded together. Again, the welding is done on 4-point welders. Once the mainframes have been welded and the sash have been welded, the 2 are assembled together and moved into the inspection area. After the pieces have been inspected, they are now ready to be shipped to an area of the plant where the insulated glass units will be installed in the products. Once the sash, mainframes, and IG units arrive at the glazing lines, a wet glazing compound is applied to the sash. If a window unit has more than one sash, the glazing compound is applied to both units simultaneously. Next, the IG unit is placed into the sash and then the glazing beads are inserted to the outside. The units are then cleaned and inspected again for quality assurance. After the units are glazed, important and unique product labeling is applied to each unit. The NFRC label is unique to each window and contains the structural and thermal performance testing data on each individual unit. This label also contains the Energy Star rating. The Simonton order number label is typically placed in the head and on the sash of each unit and is unique to each window. It should never be removed by homeowners or installers because it contains important order information that allows us to service the unit and supply warranty replacement parts should an issue ever arise. Another important label that provides peace of mind for homeowners and installers alike is the AMA Gold certification label. Simonton maintains the highest third-party product and manufacturing quality standards as prescribed by the American Architectural Manufacturers Association, or AMA. The AAMA Gold Label standard means that group can make special unannounced visits to our plants twice a year and pull actual units off the production line. In doing so, they ensure that those units are functioning exactly as they were originally tested to perform. This is voluntary quality manufacturing assurance for our customers at the highest level. After the products are labeled, they are prepared for shipment in our product packaging area. Special corner reinforcements and protectors are applied to all units. Next, the products are stretch wrapped to keep dust and dirt away from the units while they're on the job site or in storage waiting to be installed. Award-recognized satisfaction from homeowners and installation professionals nationwide isn't something we take lightly. Simonton windows are carefully inspected every day to ensure they meet the highest quality standards in our industry. Our relentless pursuit of quality, on-time and complete orders has led Simonton to become a leader in our industry. For over 65 years, we have been delivering quality products, on time and complete, to ensure customer satisfaction at every level in the supply chain. Distributors, contractors, and homeowners nationwide all experience this unique value proposition day in and day out. We hope you enjoyed this video tour and hope you get the opportunity to personally visit one of our manufacturing plants soon. If you would like to schedule a plant tour, contact your Simonton sales representative or supplier today.